All right, welcome back, everybody. Today we are going to be talking about SR1, which is what we call simplest radical form. Now, SR is going to stand for simplifying radicals. That's what this whole chapter is going to be about. The skills we're actually going to learn about today are going to be absolutely critical moving forward, so this is an important one to pay attention to, take notes, and if you do have any questions, make sure you get out there and ask them. Now, just looking at our document here, it says list of perfect squares up to 100. So the perfect squares, as you may well know, are when you take a number and you square it. So let's start with 1. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81, and 10 squared is 100. Now, these are not all of the perfect squares, right? So the perfect squares are these numbers down here. The number or the row above is where they come from. These are not all the perfect squares. The perfect squares kind of continue forever and ever, but knowing these first 10 or so numbers, or all the ones that are less than 100, ends up being kind of important for what we do. Now, down here it says write each expression in simplest radical form. The way I want you to do that and to think about that is by coming over here and looking at the prime factorization of 12. So what we want to think about is what numbers divide into 12. Well, 2 goes in 6 times. Now, there's nothing else that goes into 2, right? 2 could only else be written as 2 and 1, but we're basically at the same point. So we actually don't break down 2 any further. When you get to a number that doesn't break down any further, what we're going to do today is circle it. Then we get to 6. What numbers go into 6? Well, 3 and 2. 3 doesn't get any smaller because only 3 goes into it, and 2, again, does not get smaller, so we can circle these because they're ending numbers. Now, what that means to us is that we can actually rewrite the square root of 12 as 2 times 2 times 3. Now, what we're going to do next is what I like to call a 2-for-1 special. Anytime you have 2 of the same number, which we do have here, we can pull one of those to the outside. And when we pull it to the outside, these 2 actually cancel out. So I'm going to have a 2 on the outside, and on the inside, I'm going to have the square root of 3, because 3 was still stuck in there. We weren't able to pull that out. Let's look at another problem. So here's another one, 32. To break down 32, right? Let's think about it as, maybe you think about it as 4 and 8, and 4 would just be 2 and 2. Now those are ending numbers, so we're going to circle them. 8 is going to be 4 and 2. 2 is the ending number, and 4 is 2 and 2. So once you grab all of your ending numbers, the circled ones, we can rewrite 32 as the square root of 2 times 2 times 2 times 2 times 2. Normally, I like to write the numbers inside the square root from least to greatest and in order. Now, again, we want to do our 2-for-1 special. So we have 2 2's here, so we can pull 1 2 to the outside, and then those 2 go away. Same with over here. If you have 2 2's, you can pull 1 2 to the outside, and these will go away. Now, this is where we got to be a little bit careful. We kind of put these 2 numbers next to each other right here, but it doesn't make 22. What actually is happening here is these 2 need to be multiplied. So 2 times 2 is going to give us a 4 on the outside. Then we're going to have our square root, and inside our square root, we had a 2. So that's going to stay inside just like that. Nice job. Let's do another one. Now, this one's unique. It has a negative 3 on the outside. Let's see how to deal with that. The first thing you're going to want to do is break down the radical just like we've been practicing. So 28 is 4 and 7. 7 doesn't get any smaller, so we're going to circle it. 4 is going to become 2 and 2. Now, when we look at this, what this means is that we can rewrite the radical as 2 times 2 times 7. What we can't do here is we can't forget that we have a negative 3 out front. So we're going to put that negative 3 out front yet again. Again, at this point, we want to look for any 2-for-1 specials. We can do a 2-for-1 special on the 2's. We have 2 of the same number, so we can pull one of them to the outside. And just like before, if you get multiple numbers on the outside, we multiply them together. So 2 times negative 3 is going to give us a negative 6. And we'll still have a 7 that wasn't able to get paired up and pulled out, so he stays inside. Nice job. Let's look at another one. So here's problem number 7. So 50 is 2 and 25. 25 is 5 and 5. So we can rewrite it as 2 square roots of, that 2 was the outside 2, 2 times 5 times 5. We can do a 2-for-1 special on the 5s. So we're going to be able to pull a 5 out. These two are going to be multiplied here. So 2 times 5 is going to give us 10. And then we still have this 2 inside the square root. So we're done, just like that. Let's look at number 9. Number 9 is going to be a little unique for a different reason. When we break down 64, maybe you'll break it down as 2 and 32. Now, 2 doesn't get smaller, but 32 can turn into 2 and 16. 16 will break into 4 and 4, and 4s break into 2 and 2, and 2 and 2. Now, one thing to know about this is if you broke it down a different way, you should still get the same ending numbers. That's kind of one of the nice things about this is we do have a little bit of flexibility as to how we break these numbers down. So we're going to get our 8 on the outside, and then on the inside, I'm going to have my 6 2s. Now remember, anytime you have 2 of the same thing, you can pull one of those to the outside. Here's another one. Here's another one. So on the outside now, I have 4 numbers. 2, 2, 2, and 8. To deal with those, we need to multiply those together. Let's grab a calculator. 2 times 2 times 2 times 8 is 64. So we are going to have a 64 on the outside here. Now, one thing that's unique here is that inside of our square root, there was nothing left. We didn't have any numbers that were left over. This is different than every other problem we've seen so far. When this happens, and there's no number inside the square root, then there's no need for a square root anymore, and we get rid of it. So our final answer here is just a positive 64. Nice job. Let's look at another one. Oh, actually, that's it. So, oh, maybe it's not. Hold on. There we go. So looking at number 11, breaking down 125. This will turn into 5 and 25, and 25 is 5 and 5. So I can rewrite this as 5 times 5 times 5. 2-for-1 special. These two go away. So my final answer will be 5 square roots of 5. Now, just looking through the rest of this, all of this looks pretty standard until you get to number 19. Number 19, we introduce a variable. Here's how you would handle it. Let's start with the number. So 49 would be 7 and 7. And neither of those get any smaller, so they're both ending numbers. So when I come over here to rewrite this, I'm going to have the square root of 7 times 7. Now, I also have this x squared inside. Now it's our turn to deal with that. So whenever you have a variable inside, you can write that variable out or string it out. X squared means you had 2 x's. So when we come over here, now we just want to do our 2-for-1 special. So if we have 2 of the same thing, which we do right there, we can pull out one of those to the outside. Now notice we have 2 x's as well. So we're also going to be able to pull out an x. 7 times x is just 7x. And then inside the square root, well, there was nothing left. Everything was gone, which means our square root symbol disappears, making this our final answer. One thing to realize is if we would have come over here, and when we strung it all out, if we would have gotten 7 times x times x times x, if we had that extra x in there, when you do that 2-for-1 special, there's your 7, there's the x, but in this situation, we would have had one x that was still in there. So our final answer in this problem, if this is how we would have been left, is 7x square roots of x. So the variable gets treated very much the same way as numbers do. It's just important that when you see it, that you just write it out as many times as that exponent says. I think you guys can handle it from here. If you have any questions, please make sure you are reaching out and asking. Thanks, everybody. Have a great day.